Okay, I am Allie Harvey, and I'm going to be reworking Madi Hettich's Chapter 3, Problem 383. The problem is of a steam pipe of known parameters of our length, radius, temperature difference, price of heat loss per kilojoule, and our needed efficiencies. So first we need to find the rate of heat loss, the price of this heat loss per year, and the thickness of insulation needed in order to save 90% of this heat loss. So going down to my solution, we have, first we're solving our heat loss, so this is just Q dot equals H area times our change in temperature, all variables that we know and are given, so we can calculate to 42.4 kilowatts. Second, we need to find the cost of this per year. So given, we just calculated our Q loss, and we know how much it costs per kilojoule. So from there, it's just a unit conversion to get to $8,790 per year. And then for C, if you're wanting to save 90% of the heat loss, that means only 10% of that heat loss can be used. So we're setting that equal to our temperature difference over our resistance total. And our total resistance is equal to the individual resistance of the insulator and the resistance of the air. So each have different equations to solve for. First, with our insulator, we have derived that our insulator equals our natural log of our outer radius divided by our inner radius divided by 2 pi LK. So from here, we need to know the thickness, so that is where that T comes in, and also on the bottom. Moving on, for our convention, or for our resistance of air, we have 1 over HA, all variables we know, so we can just straight solve for that. Our total resistance is equal to the sum of these, and we're setting that equal to our required heat loss below our temperature difference. So from here, we have an equation with one variable, but this is difficult to solve by hand, so we didn't end up using solver and isolating that thickness to equal 0.261 meters. Maddie and I did very similar things in our approach. I think Excel solver was the best option. We both ended up doing that before we checked, and just making sure we're using our correct equations for our resistances, which we both did. Overall, we ended up with the same results, and she did a great job.